Otherwise, I'll be going on. So V equals R times W. We know A equals R times alpha. We know X equals R times theta from 2 slides ago or 2 videos ago. Centripetal force is V squared over R from a long time ago. Seems like a long time ago. And since V equals R times W, you do that substitution here, you end up with R squared over times W squared over R, which is R times W squared. And force equals mass times acceleration, so it's mass times the acceleration, which is RW squared, and that's where the equations came from. So you can calculate centripetal force both ways. If you know the linear V, we can use that. If you don't know what the linear speed, you know what W is, you can use this one. You can calculate the centripetal acceleration using this if you know V and R. If you don't know what V is, you can use this one if you know R and W. So it depends what you know. Let me take an example here on some of these, and that'll be the last thing for today here. CDs. Anyone has CDs at home? Okay. Usually the CD has a linear speed, V, not W, is equal to 1.25. They spin them at the rate where they have the linear speed 1.25 meters per second. Find the angular speed. Find the angular speed when to read the CD, by the way, there's a laser beam. They fire this light, and they call them pits and hole. Pit, which is a hole there. So basically, your CD looks like this. If it's nothing burned, you shine a beam like this. Laser bounces back, the receiver will get it. So this is going in, this is coming back. When you burn the CD, what you do when you're putting a hole there in it, it's called a pit. So when you shine the light there, it doesn't reflect where it's supposed to go, it goes right there. So the receiver here does not see it. And that's how they know if it's 1 or 0. So it depends where that receiver is or where the beam is. So let's do it when R equals, I don't know, we'll use 2.5 centimeters. And the second part when R equals, I don't know, 6 centimeters. You want to use 6? Find W. Here we go. V equals R times W. For part A here, V is 1.25 meters per second. R is 2.5 centimeter. You have to convert that to meter. That's 0.025. They're divided by 100 times W. Can you get what W is? .25 divided by 0.025 spins at the rate of 50 rad per second. For part B, again we use 1.25 equals, instead of 0.025 or 2.5 centimeters, 6 centimeter, which is 0.06. So W for that will be what? 1.25 divided by 0.06. It's 20.1 or 20.8. rad per second. You can use the same logic when you watch the ice capades. A lot of times at the end of the show on the ice capades, what you see, people holding hands, about 10 skaters holding hands. The next skater. And we'll do like this. And let's say they want to spin around. A lot of times they spin around the person in the middle there, but let's say they're going to spin around this end, this person at the end here. So this person is going around slowly. That one on the outside has to travel much bigger distance. So he or she better be moving a lot farther or faster because their distance is much larger. Notice right there. If you ever go to a track like the YMCA, they have these track. If you want to run 1 mile, it says on the inside it's 21 laps. On the outside is 16 laps. Why? Because you're going farther on the outside. Well, that's the same thing. This one has to go way farther there. That distance traveling much bigger than the one on the inside. So if we just take two people, this person, for example, will say the distance right here is, I don't know, let's say 2 meters. But this one on the outside, the distance is 4 meters. They're all holding hands, so they're going on the same angle or speed. The angle is the same, so when you look at them like this, when the group is right there, notice it's right here, then the group is right there. So the angle or speed they're spinning, it's really constant for them. So we'll say W for them, I don't know, let's pick a number, 3 rad per second. So how fast the person on the outside moving versus this person? We'll call him number 1 here, and this is number 2. What is the linear speed for number 1, and what's the linear speed for number 2? V equals R times W. For number 1, R is 2, W is 3, that's 6 meters per second. The outside person has R equals, again, R times W. R is what? 4. W is 3. And he's going or she's going at a speed of 12 meters per second. Twice the speed of this one. Twice that speed. So if you're just focusing on few of them, you'll see this one goes, wow, he or she really fast. This one, oh, it's not that bad. The closer you get to that, the slower you're moving. The farther you go, the faster you're moving. You can use the same logic when you go again to the merry-go-round there and you go on a horse on the inside versus the one on the outside. The one on the inside moving slower linear speed versus the one on the outside because they have to cover a much farther distance. Let's do something with the acceleration and the centrifugal force and send you home. Now we'll take a centrifuge here, and if you've seen one, I used to work in the lab when I was young, when I was in college. My job was to pick up the stuff. The centrifuge will have like 4 pieces in the middle, they spin. And you'll see them actually take a vial and pull one here on this end. And you got to balance that, you got to pull one on that end. And if that's all you have, a lot of times what they do, they put empty ones here with nothing in them. glass or maybe just some water, whatever liquid, just to make sure it's balanced. But I'm only interested in these two, the ones with the blood in them. Let's make the blood. Here we go. And spins at a high rate of speed. So these tubes actually, these two red ones have the blood, and then we try to separate them to see if you're sick or anything. The tube, let's say, are rotated. Ready for this? At. Doesn't say initial final. Rotated at 11,500 RPM. And the distance from the center of this device, from here, the radius, to the outside is 9.07 centimeter. And we're going to spin them counterclockwise this way. As I said, the speed 11,500 RPM. I need to calculate what W is for that number. I need to calculate what V is, linear velocity. I also need to know what the centripetal force or centripetal acceleration, we'll do this. I don't have the mass for them. For a piece of blood on the bottom of that tube. Well, the bottom of the tube almost touches the edge of that. So I'm going to use the distance for a piece of blood on the bottom of that to be 9.07. So I'm talking about the bottom of the tube. We're assuming actually this spinning at constant speed, so that's why I'm not using initial final. Once you turn the switch on, ignore the first 2 milliseconds there. When you turn it on, it's not moving, it's going to start to spin. But after like a millisecond or 2 milliseconds, the thing is spinning fast at this rate. So using that as W, well, it's not really W because W would be radian per second. What is that number in? RPM. So let's convert that to radian per second. To convert that, I need to convert revolution to radian. 1 revolution is 2 pi radian. And also I need to convert what? Minutes to second. 1 minute is 60 seconds. Rev cancels the rev, the minute cancels the minute. That's why I put them in these spots. 11,500 times 2 pi divided by 60, so you have an idea how fast that thing spins. 1204.3 rad per second. I mean rad, not rad. Oh yeah, it was rad per second. We're looking for W. I forgot what I'm looking for. Velocity V is R times W. R is what? 0.0907. You have to convert that to meters. Times W, which is 1204.3. Which is 109.2 meters per second. That thing spins. Just to give you a heads up there. Spinning at a speed of 246 miles per hour. So if you have a string attached to that and that string keeps wrapping itself around the thing, you'll see that spring moving on, the string moving on the ground at a speed of 245 miles per hour. What's the centripetal force? I can use either one. I can use RW squared, or I can use V squared over R. I'll do them both ways to show you the answer. It doesn't matter which one I use. R is what? 0.0907, and W, which is what? 1204.3 squared. Here's the centripetal force. If I did the math correctly, I don't know if I squared the number. I can't remember now. Yeah, I did. Did you get 131,545.7? And if I did it the other way, let's see, V squared over R. V is 109.2. Square it, divided by R, which is what? 0.0907. Do we get the same answer? 109.2 squared divided by 0.0907, 131,473.4. I'm sure it's rounding error. 131. If I carried all decimal places, will be the same answer. Matter of fact, I'll go back and carry all the decimal places, see if the answer is the same. Where is it? 11500 times 2 times pi divided by 60. So it's 1204.27. So if I use that number, square it, times 0.0907, 131,540, if I carry all the digits, and I'll carry all the digits for both them. .7. Now let's use that one. Let me find V. Let me do that again. 11, carry all the digits. Times 0.0907. So V is 102.22. So let me carry all the digits. Here's V. Let me square it now. Can you see them on the? Let me square that number. God, go away. And divide it by 0.0907. The answer is 131,540.7. Is that the same answer when I cover the calculator and cover it? Look at that. Doesn't matter which one I use. If I carry all the digits, no rounding, my answer is exactly the same. Okay, we're going to stop here. Looks like you are beat. Looks like I am beat too. So tomorrow we'll finish it.